Welcome. Let's solve Leetcode 1930 unique length 3 palindromic subsequences. Okay, so let's make this bigger so it's legible for both you and I. All right, let us begin. Given a string S, return the number of unique palindromes of length 3 that are a subsequence of S. Note that even if there are multiple ways to obtain the same subsequence, it is still only counted once, okay? Let's go over what a palindrome is. A palindrome is a string that reads the same forwards and backwards. A subsequence of a string is a new string generated from the original string with some characters, can be none, deleted without changing the relative order of the remaining characters, okay? So let's get started here. Okay, let's look at this here. So looking at this here, this first example, we have the string AABCA, AABCA. And if we consider the first A and the last A, and then the character B in the middle, that would be our first example of a palindrome. Next, we can consider this first A, this next A at index 1, and then the last A in the last index. That would also be a palindrome. And lastly, we can use the first A and the last A in the last index, and this C right before the last index, or the penultimate index, as some would say. And this would also be a palindrome. And hence, there are a total of 3 palindromic subsequences in the string S of length 3. Okay, in example 2, there are no palindromes of length 3. And I think example 3 is straightforward, so we can just move on to how we'll solve it. Okay, so I think that's enough for us to get started. So let's go over some, what's the word? Let me see. Some things we noticed. Yeah, some things we noticed. Okay, so let's just first start with maybe, we can use this as the last example, it's fine. Maybe not. All right, so for me, what I first noticed is like, what is most important is the endpoints. What is most important are the endpoints. The endpoints. Okay, so what I mean by that is this. Suppose our string is I'm gonna add a z here. Can we have a palindrome? Can we have a palindrome? Can we have a palindrome? Palindrome with the letter z, z as endpoints. Well, that's a good question. It looks like we only have one z, so no, we could not. Could we have? Let's ask another question here. Could we have a palindrome with the letter? How about the letter y? And no, right? Because there aren't any y's. Now, sorry, there should be a b here. So my point still stands. We're most concerned with the endpoints. Okay, so suppose we find an endpoint now. So we find a z here. So if we're looking at the z here, we are only concerned with what in the middle. So we have an a here, right? So this, we have this a here. We have this a here. And remember, right now we're focused on this, on the z's here, the z and this z over here. Z. We have an a in the middle. It doesn't really matter where it is, but well, let's consider this first one here. this is a palindrome. So this is one palindrome. Does it matter now if we choose this A instead? No, right? Because we're not concerned with, we're only concerned with the unique palindromes. So what does it say? Note that if there are multiple ways to obtain the same subsequence, it is still only counted once. So we don't really care if there are like multiple A's or what I would call internal values. We just care about the unique values. So this is one. Well, how many other values are between these Z's? Well, they have a B here, so it doesn't really matter where it is. There are many B's, in fact. But we can just choose one, and that's all we need to do. And C. And we have C. So my point is this. Once we have our endpoints, we are now concerned with the number of unique, what is it called? I guess characters between our endpoints. And that's most of what I wanted to go over. The last thing I want to go over is our endpoints exactly. Okay, so in this case, we have an endpoint of Z and an endpoint or Z so far. How many potential endpoints can we have? Let me ask that question. How many potential endpoints could we have? Well, we know that, well, what do we know? Let's see, here it is. We know that our string only has lowercase English letters. So in this case, our endpoint was Z. What I'm hinting at is, don't we know that the best we can do for endpoints is the letters A through Z? So we could at most have 26 different endpoints. Okay, that's my point. And then we'll be using this when we write our solution. We code up our solution. Okay, so I think this is enough for us to get started. And well, let's do that. So what I'm going to do is I'm going to initialize our result here, and I'm going to just get it out of the way and return result. Okay, so remember, we know we could only have 26 different endpoints, which are the English letters. So let's try with that. We'll say we'll say maybe letter in. Now Python comes with a nice module for helping out in this type of situation. They have this module here. What I'm going to do is just print it out for us. So let me see. I'm going to say print string dot ASCII lowercase. I'm just going to print that out so we can get a look at it, and I'll just do nothing here, and I'll return the result. I just want us to see that. So it's just going to be the English letters. Yeah. So I just wanted to see that. Now let's get back to our code. Okay, what next? So for this letter, we want to find where the endpoints are. And so remember, once we find our endpoints like Z and Z, we want to find the unique letters between them. So right, remember that once we have our letter endpoints, we want to find the number of unique characters between our endpoints. Okay, so how can we find our endpoints? So for each letter, those are the possibilities. Python comes with a very nice method for this attached to the string object. It's called find. So this will return the index of the character that we're searching for. So in our case, we have the string S, and we want to find from the left where this L character is located, and this will be our left endpoint. And then the string class from Python also provides another method called s.rfind, and this will find this letter, but starting from the right. So my point is, if we were to run this here, this string.find, so if I do s.find z, it would give me something, it would equal 1. And if I did s.rfind z, it would give me, I don't know what that is, 2, 4, 6, 8, 9, 0, yeah, I think it's 8. 0, 1, 2, 3, 4, 5, 6, 7, yeah, 8. So we would now, once we know our endpoints, then we can find the number of unique values between them. Okay, so that's why I did this here. And we'll set this as maybe, I don't know, maybe, I'll just call it left and right. Okay, that's fine. Now, suppose our letter does not exist. So find returns a -1 if that letter does not exist in that string. So what we can do is we can set something like if left is greater than -1. We could also do right to be more I guess clear, but this is also fine. The reason why we only need 1 is because of this. So let's go back up here. Suppose we have this here. So when we use left find and right find, they would both be 1 in this case, because if we look for z from the left, it's 1. If we look at, sorry, the index is 1. If we look for z's from the right, starting at from the back, it's still going to give us 1. So once we know our endpoints, we can say, when we look for the number of unique characters between our endpoints, well, there would be no characters between itself. So that's why it doesn't matter. We don't need to check both. So in this case, if we find 1, then we can just go ahead and pretend like both endpoints exist. So how do we find the number of unique endpoints between our endpoints? Well, we can use the slice, Python list slice, or string slice. So we can say s is our string, and we want to know between our endpoints. So we'll say, okay, starting at the left, +1, and to right, because remember, right is not inclusive for the string slice. Okay, and then we say, okay, what? This is the string though. We want to convert this to a set, so we know we get the unique values, because there could be many of the same type. Okay, now we have this set, and remember, once we know, like in this case, once we know that we have, well, in this case, remember we had 3 unique values. That's how many palindromes existed with z as an endpoint. So we can say, okay, we can say the length of that is what we're concerned with, and we can add it to the result. I think we already did that. Let's erase this print here, and let's run it. What went wrong here? Hold up. Wait a minute. Something ain't right. This looks good. Oh, I see. Oh, no, everything. No, that's correct. This is good. This is good. Left, right. This left is greater than length of set. S of left +1 to right. Oh, I'm sorry. I'm supposed to add it here. Okay, that should be better. I did have one. Well, let's submit it first. Okay, that looks really good. I was going to say I have an optimization, but I don't know if it's an optimization. It's just a curiosity, and we can't really do better than 99%. But I did have one last thing. You can probably stop watching the video, but I had one last thing. Now notice here, we're looking through all the letters, like for example, this is all the letters, right? This is A, B, C, D, right? All the way up to Z, right? Now, my thought is this. Like our string may not have all the letters. So my point is this. What if we change this to the letters we have? So what if I said L and set S? So now, like for example, so instead of like looping all through these letters, if our string was, like for example, in this case, we would only have, the only possibilities would be, for this first example, would be A, B, or C. And that makes sense, right? We couldn't have, like, it would, like the way we had written it before, we had like all these other letters, but there's no way we can have like a palindrome that had X, Y, or Z as the endpoints. So I think this will work too, and I think this is maybe a little bit more makes more sense. Let's try it out. Okay, and let's submit it. And now it's not going to probably do. It might even perform worse, but I'm curious. Yeah. So in any case, it's just it still performed well, but I just thought that this is probably a little bit more along the lines of what it should be, and hopefully that makes sense to you. Okay, if you found this video in any way helpful or beneficial, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself.